welcome you to today's webinar on using water wisely and using the soil continuous remote soil moisture monitoring as a key tool to using water wisely. So just to start out, just a few kind of logistics around this webinar. We've got quite a few people on, so everybody is muted and in listen-only mode. We do want to solicit you for questions, and we will answer all questions at the end of the webinar. There's a question dialog box that you could open up and type in your question at any point during the webinar, and at the end we'll start going through them and answering them, and also at the end of the webinar we'll just do a kind of an interactive Q&A for anybody that's interested. We'll be recording the webinar, and it'll be posted on our website. So if you want to look at it again or point somebody to it, that'll be available. So we're at this point, I want to introduce Mark Greenspan. Mark is the president and founder of Advanced Viticulture, and really has been doing soil moisture monitoring and all matters related to irrigation in vineyards for many years now. He's been a ranch systems reseller for I think at least 4 years, and is very expert in using capacitance probes and remote soil moisture monitoring, and how that impacts irrigation and water usage. So this is the third time that Mark is doing this webinar for us, and it always attracts a large following. So I think we're fortunate and grateful to have Mark share his knowledge and expertise for many years of working with soil moisture monitoring. So with that, I'll hand it over to you, Mark, and thank you.
Thanks, Mike. I'm going to assume that if I don't hear anything, you guys can hear me okay, and because I am talking to my screen, basically. Yeah, thanks a lot for coming, and I really appreciate everybody tuning in to this webinar. It seems like an annual event now, and if you were here last time, you may see a lot of the same material. Hopefully this time you'll maybe get a little bit more out of it. There's a few new things I got for you, but primarily we're just talking about the same method. Every year I seem to get a little better at it. I guess that's kind of, hopefully that's the trend for everybody who's using it, and if they're not, hopefully I can get you interested in looking at it. Water's not going away as a problem, and in vineyards especially can be very thrifty water users, and a lot of growers don't seem to grow their grapes that way, but they can, and it's really not that difficult, and that's kind of why we're having this webinar. I've got a few starting points to talk about, and hopefully my computer will advance the slide as I'm trying to tell it to. All right. I also realize there's a bit of a delay working through this before the webinar, so I'll try to remember that and go a little bit slower, but I may actually slip once in a while in my excitement to get this thing on the road. These are just some points I wanted to make. I don't usually start the talks this way, but I'm going to start doing that now because, after doing this for a number of years and working with a lot of different clients, and I've never ever once found that we need to irrigate more. It's always been we can irrigate less. Oftentimes we're just changing the way things are irrigated. The schedule changes from potentially from maybe long irrigations to shorter irrigations more often. But it's there's almost no situation I've ever walked into that couldn't be improved. So my first bullet is, unless you dry farm, you can irrigate less than you do now. I can say that almost unequivocally. There's probably a few out there that perhaps doesn't pertain to, but I feel pretty confident that 99.5% of you can irrigate less than you do now, unless you don't irrigate at all. Now on the North Coast, we have a pretty special growing region. It's true for some places in the West Coast, but mostly Pacific Northwest and Northern California, where we have a fairly wet winter every year. Even in drought year like this year, we got 25 inches or a little bit more, plus or minus this year. So we normally start the year with a pretty full soil moisture profile. That means we can usually delay our first irrigation into summertime. Oftentimes in July, and sometimes even into August and September, we've been able to delay irrigation. I'm not talking about this year particularly, and specifically we've had some issues with, well, we haven't had any rain since February, so we actually are doing a tiny bit of irrigation just to get the ball rolling, but after that we're not looking at irrigating for quite some time after that. So this year, even though it's a drought year, last year, even though it was a drought year, we're still irrigating pretty late to the season. We're holding off that first irrigation. I usually irrigate, and I don't use ET as my bottom bullet point says. I don't use ET, the evapotranspiration model, any longer. I used to use it. I found that when I did use it, I irrigated too much. I use the soil moisture probes, and I found that when I do use the soil moisture probes, when we're irrigating, I'm not talking about all season long, but during the period while we're irrigating, I'm usually irrigating about 20% of the crop ET, which is way lower than what we used to use, which is that's 60%. I hear a lot, and I used to use it, 60% of crop ET. I say it ain't really a deficit because I'm irrigating about a third of that, and without vine stress, without excessive vine stress, let's just say that. I wouldn't feel good about doing this if I didn't have these tools, though. I wouldn't feel confident. And that's what I said here. That's a minimal amount of irrigation to put on vines in many cases. But if I didn't have the monitoring tools, that means the soil moisture, the plant moisture stress tools to give me feedback, I would not want to go that far. The last bullet point, I don't want or need ETO, the reference ET models, which that's just my personal opinion. I used to use ETO as a guideline for irrigating, and I found that when I did that, I couldn't push that. All right, so today I've only got a few things to say. We've only got an hour, and it's an hour is just a flash in time to talk about all this stuff. But I want to give you the basics. So I want to talk to you just a little about my approach for irrigating using the soil moisture probes. It's key to this discussion, and there are other ways to do this, and there are other new tools coming online that we're starting to see, some new technologies, and they're all great. Well, I wouldn't say they're all great, but a lot of them are very good. Some of them may be great. Some of them are probably need a little bit more development. But I find that soil moisture measurements is really fundamental to the whole process, and I don't think that any of these tools that are coming out will replace, in my mind, will replace the soil moisture device. So I want to focus not on just the moisture content. I want to focus on soil moisture dynamics, or the changes in soil moisture that we see. So I don't really use these devices in a highly quantitative manner. I use them very qualitatively, as you'll see. But I think it's very important to provide some measurement of plant moisture status when we're doing all this irrigation management of wine grapes. Not only because we want to control the stress, but we also don't want to go overboard and cause too much stress on the vines, which could cause crop loss, quality loss, etc. So it's very important for me to measure the plant moisture status along with the soil moisture status. The benefits of real time, I actually put that bullet point in there, but the benefits of real time are really about making decisions in real time. Not having a data that's a week old. I mean, obviously we need the history, but we want to make our irrigation, when we're irrigating, I say irrigating on the edge, with very minimal amounts of irrigation. We need that information in a timely manner. That's where the telemetry, the ranch systems especially, comes in not just handy, but it's really almost essential to have that information that you're getting vineyards in the North Coast, and I see irrigation as just a little patch to get us through that last bit of summer into ripeness, and then rehydrating the vines after harvest. I don't see it as a means to build a root system. I don't see it as a means to really farm the grapes. I really see it as a supplement to the natural rainfall. Now I say that knowing very well that some areas in the state and in the country do not get the same kind of rainfall patterns that we get here in the North Coast, which is ample amounts of winter rainfall and summer drought. Some mostly about the way I do it here in the North Coast. But whatever the case is, I hear people saying we want to drive the roots down with irrigation. And that really doesn't work very well. It doesn't work well because the way when we irrigate with drip irrigation, and 99% of our vineyards are irrigated with drip irrigation, as good a system as your drip irrigation is, as good a tool as it is, it does not do a very good job driving water deep into the soil profile. And so what I try to do is delay the irrigation to let the roots chase the rain-fed moisture. They do a much better job at doing that than I can do with supplementing or mimicking rainfall with a drip emitter. So that's how I encourage a deep root system, is to allow that root flush and that root growth to occur in the springtime with the natural rain-fed moisture as much as possible, and delay that first irrigation. And when I find that I do that, I can actually delay it longer and longer every year. Each successive year, we seem to be able to delay that first irrigation longer. That's because we're developing a bigger, more extensive root system. And so you see me here in this soil pit, just kind of looking. I'm actually showing, this is a demonstration. I'm just showing, and you can't see that in this photo, the root system of this vineyard. And this is a 03916 Cabernet Sauvignon 03916. You think it has a super vigorous, extensive root system. Well, grapevines don't have a terribly extensive root system. They have a very sparse root system. And even in 03916, which is a fairly vigorous rootstock, we saw most of our roots in the upper 3 to 3.5 feet, meaning I don't want to push water down much below that 3 feet level. And if we do, we're mostly wasting the moisture. Some of it can come back up through capillarity in the soil matrix, but lots of times we will actually just be wasting water. So personally, I find it very useful to irrigate only a portion of the root system when we're irrigating at all, because having a portion that's dry and a portion that's wet actually triggers some physiological processes that are beneficial to the vine, triggering some stress response without actually stressing the vines. That's something that I won't go into today, but you may have heard of partial root zone drying. I never found that to work very well with using 2 irrigation systems, but I found we can actually cause the same or create the same physiological response by irrigating only a portion of the root system and leaving the other portion dry. So that's kind of what I do, but it's very important to know where that root system is before you just start taking guesses at it. Now what you'll find out, I'll show you in a few slides, is that we can actually use the soil moisture probes to identify where the primary roots are, even without digging backhoe pits, which is I've found very useful for a lot of growers. Just a couple of quick pictures, probably slowly coming up on your screen, just to show you that root systems in grape and vineyards are not always terribly extensive. These are 2 very shallow sites. This is in centimeters. I guess I put the wrong slide in here, but anyway, you kind of get the idea. This is 25 centimeters, is what, 10 inches, 10, 20 inches. So what we're looking at here is a scale of about 20 inches. And you see these roots over here on the left, extremely shallow. This is a problematic site which has actually been replanted since this photo was taken almost 10 years ago. And the roots were not growing into the lower depths of the soil because it wasn't amended properly. And this one on the right is just a shallow site. Actually, the soil was scraped off, filled in another location, and you'll see that the root system is not very extensive and not very deep. I like to bring out this next photo, this next image, and this is an aerial image of a vineyard. Actually, the right-hand photo on that last slide was taken right here in this weak zone. So this is an NDVI image. The NDVI shows green in the more heavily vegetated areas, orange or red in the more weak areas. And so you see in this particular block, the block actually goes like this. It's a rectangle, almost north-south. It contains vines that have deeper roots, like 41 inches, and then vines that have shallow roots. And so this is kind of a typical vineyard, really. Not always this dramatically different, but pretty much any vineyard you walk into is going to have some variability. And so I think irrigation gives us a potential tool for evening out that variability, but we have to be wise in how we apply it. And you may have seen this before if you've seen my talks. I like to bring it out because people always tell me they kind of gives them the idea of what we're really doing. This is a schematic of a vineyard. Let's say that's that last vineyard that we just looked at with the aerial. On the left-hand side, we have either shallow soil, it could be a rocky soil or a sandy soil, and more or less just a soil that has lower water holding capacity. And on the right side, let's say it's on the same row, we have that deeper rooting system with either deeper or higher, or otherwise just higher water holding capacity. And so I would say, how do you irrigate this? Do we just pick a point in the middle and irrigate for that, and then we'll have some weak area on the left, and we'll have some maybe overly vigorous area on the right? Well, let's try not to have that situation. Let's try to mitigate that variability. And so what we normally do, this is going a little bit outside the scope of what we're talking about today, is we usually put a second set of emitters in there. So a second poly line in there with the emitters. And we irrigate that weak section. And really what we're doing is not necessarily irrigating it more, but we're actually turning this line off, the one with the red emitters, and the one with the blue emitters, we're turning that on early in the season, because this is going to run out of moisture earlier than this on the right. And so we irrigate this. Now once these vines here on the right slow down, get under control, then we can go back to the original emitters. But back to the crux of this discussion is, how do we irrigate this vineyard once we're irrigating the whole thing? Typically what people will do is kind of shoot for the middle ground here is sort of around here. I'll irrigate this much. That means this area here won't have enough water. Well, it's getting more than it can handle in this area here. Well, it's getting enough water. That's fine. But what happens is over here on the left is, if you irrigate more than the water holding capacity of that soil, you're going to lose either water below the root system or you're going to have some other way of losing water. It could be runoff, could be other kind of redistribution down a hill. Whatever the case is, you're losing water on this side, and you're maintaining the water on this side. What happens is, if you irrigate everything the same, is between irrigations you've lost some water over here, which means that between irrigations, before the next irrigation, this side here is going to become stressed, and this side here is not. And so the problem there is, when you have stress, it creates a weak vine. Weak vines kind of perpetually stay weak, and strong vines perpetually stay strong. So you kind of perpetuate that in the variability or the heterogeneity in that vineyard, and we don't want that. And for fine wine grapes, we want everything to be the same as much as possible. So my approach then is, and you probably can't see the animations here very well, but anyway, you get the idea. I'm irrigating small amounts. We're irrigating to the weakest portion of the vineyard, or at least the weaker portion of the vineyard, meaning we're not trying to irrigate the whole root system across the board. We're trying to irrigate the root system of the weaker zone, and that also means we're going to have to irrigate more often. So this is kind of what's called the small drink. At least that's kind of what people are calling it. That's been my approach, and that's been a very successful approach for me. A lot of people don't agree with me on that, but actually more people agree with me on that than don't. Let's just say that. I found a lot of vineyards that were using the other approach that we've really fixed by taking this approach. People say, well, we're encouraging a shallow root system. Well, that is not really the case, especially in the North Coast, because we are trying to delay our first irrigation until late in the season anyway. So we are actually encouraging deep root growth. But this irrigation method works much better at maintaining the vines for through the rest of the season, through harvest. When those vines are stronger, they come out stronger the next year, and the more they do that, the more we have a uniform vineyard rather than a non-uniform vineyard. It's also true that when I do my monitoring, I want to monitor that drier zone. So I dropped in a soil probe here. That's really where I usually put we use aerial images, we use soil maps, we use grower experience, and we generally plop our soil moisture monitoring tools in the weaker zones of the block, and that's our control point. So we're talking about a two-pronged approach, soil and plant, and these are some features of the soil moisture and what we do with the soil moisture monitoring. We can identify the effective root zone using these devices, or backhoe pits, or both. We can see how the rain-fed moisture, the winter moisture, maintains itself into the spring and into the early summer. It gives us a lot of confidence, a lot more confidence than we have otherwise, that there's moisture down deep, that the vines are getting it, and we can actually see that the vines are getting it. When we see that, then I can keep telling the grower, no, don't irrigate, don't irrigate, don't irrigate. The first time we do this with growers, they get pretty nervous. And usually it takes a couple of years for them to get comfortable with this, that we can push it off a little later every year. And it really is true. It happens to everybody that I work with, that initially they're pretty scared to not turn that irrigation on in June. And so maybe that year we turn on in early July, and maybe the year after that we turn on in August. And it's pretty interesting to see how growers kind of just learn to accept this and learn to appreciate what the soil moisture is telling them. And honestly, I've had so many people telling me that they really wouldn't be confident in doing this if they hadn't had a picture of what the soil moisture is 40 inches down or 48 inches down below the surface. Then we use this tool to determine how far irrigation is going down in the profile. This is exactly what I'll show you. We can also use it to tell us when the moisture is slowing down. It's uptake, when the vines are taking up less moisture, meaning they're going into a stress. That doesn't tell us the actual stress, but it does give us a pretty good indication of when they slow down their uptake of water. And then we can use these tools to determine exactly how long it takes for that moisture that we've applied to be taken up. So there's really no guesswork anymore. That's what the ET model is, sort of a guesswork kind of a approach, in my opinion, because it's a model. It's just a model. This is not a model. This is actual measurement. So we can actually see how long that moisture takes to return back to the level before we irrigated. And so I can tell exactly how much to irrigate if I want to maintain that moisture content. So it's really about precisely irrigating or precision irrigation. Now the plant moisture monitoring devices I'll talk a little bit about today, but not a lot. It's another topic that's, I think, extremely important. It's telling us how does the vine physiology respond to the moisture content in the soil and to the weather. We want these vines to get into a state of being water use efficient, and I'll talk a little bit about that in a slide or two. But to me, this is how I can get down to 20% ET, and that's by getting the vines into a state of being water use efficient. That's why this irrigation approach seems to work, because it keeps the vine into that state for a longer period of time. Once we get it down to that state, into that state, it also, that third bullet point there, avoids excessive vine stress. If I see the vines getting overly stressed, then or even close to being overly stressed, then we make modifications to the irrigation plan, the irrigation schedule to accommodate that. If you try to do soil moisture without plant stress monitoring, you can mistakenly go overboard and overstress your vines. If you try to do just vine stress measurements, which I've tried before, you don't really know what's going on below the ground. Yeah, you can make the same mistake. So I use these two sets of tools. I rely on them tremendously. I'm kind of a numbers guy, but I think it's important to go, well, look at your vineyard too. So plant moisture is also not just measurement tools. It's also using your eyeballs and your history and your knowledge of that vineyard. So we'll focus on soil moisture measurement here for the next 10 minutes or so. I can't say enough about how much I've really adopted these as a primary tool for my work. These are some things I think are important when we're talking about soil moisture monitoring. I believe it's important to measure multiple depths of moisture. Putting one sensor in at one depth tells us a little bit, but it doesn't tell us nearly enough. So I really want to measure more than I use actual numbers. The numbers to me don't mean that much. These are very difficult instruments to calibrate. But as you may see, hopefully you'll see, you don't need to have these in a calibrated form. So the traditional way to measure water content, well, there's lots of traditional ways, but one of the most commonly used in vineyards, I think anyway, has been the neutron probe. I always say, I continue to say that it's probably one of the better tools out there. It's for getting accurate measurements of water content, but there's one big glaring omission in that it can't do continuous measurements. It can only do point measurements, points in time or snapshots. To me, it's the change of soil moisture that's important, so we want to look at it continuously. We use the tools to determine our volume, which is how many hours or how many gallons we put on each irrigation, and then we use these tools also to tell us how long between irrigations, or how long between irrigations we can go to either maintain that stress level or reduce the stress level or increase the stress level. And as I said before, it takes all the guesswork out of it when we have these visual tools. I do use them in conjunction with plant moisture stress or moisture status measurements to get our intervals dialed in, and that changes throughout the season depending on the phenology of the vine, of the fruit, and the maturation stage we're in. Just a few examples of the soil moisture types, the electronic soil moisture measurements. The ones on the left here these are two different types of matrix potential sensors. This is the watermark, and this is a device made by Decagon. Actually, this has been replaced with another revision of it. These are both very good tools, relatively low cost, and they measure the matrix potential, which is, if you will, the water potential or the suction of or the tension on the water itself in the soil matrix, meaning that when the soil gets dry, it's more difficult to remove that water from the soil matrix, and that's what these things read. They read it directly, and they actually come in contact with the water in the soil matrix. The water goes in, water comes out, these little pores, and they measure the conductivity inside of that device, inside of the matrix. The ones on the right are a different type of device. These are the devices actually I use more than these on the left. These are water content sensors. They measure how much water is in the soil, not how tightly it's being held, but they measure how much water is in the soil. There may be a slight disadvantage there, as these on the left will tell you how hard the plant has to suck to get the water out of the soil, but the ones on the right will tell you how much water is there, and actually I find them to be more useful. There's a reason for that, and I'll show you in a minute. But so these are discrete types of devices. All three of these are. They measure one point in the soil, or some of them may be oriented vertically. Some of them are bigger than others, and if they're oriented vertically, they average over a larger depth in the soil. But typically, they're installed horizontally. These on the right are the ones I use. These are the AquaCheck sensors. I've been really happy with these sensors. These are what I'll describe in the next slide. And these are, I call them probes. We call them probes because they look like a probe, but they have multiple sensors inside of them. And so we install these in the soil, and they measure the moisture profile. So here's the AquaCheck probe. This is I think he's holding a 40-inch version of it. It's sort of based on the original Centec probe. I think that was the first that came out that was released in Australia, which spawned the C probe, and the C probe spawned the AquaCheck probe, and then there's lots of others that have come based on this design. It's a very, very nice design, very simple to install, well, relatively simple to install. It's based on it's a capacitance type of sensor. I think I have a chart of that, or a schematic of that in a couple slides. Each of them have 6 sensors, and primarily we're looking at the full profile. So we usually use 48-inch sensors. The 48-inch sensors have 8-inch intervals between the sensors. 48-inch probes have 8-inch intervals between the sensors. But they are available in shorter lengths, even longer lengths. Actually, they come as long as 5 feet. And the advantage of this probe over the earlier ones, the C probe, the Centec, in my opinion, is that they're thinner in diameter. These are about 1.25 inches in diameter. I find them a little easier to install than the thicker ones, which are about 2 inches in diameter. They're filled with epoxy resin, so they tend to not only be stronger, but because they don't have an air channel inside of them, we don't see the thermal effects as much as we do on the older probes. So we get a very clean signal to look at, and I'll show you some of the charts. Hopefully you'll see the same thing. Okay, I'm getting a little bit of a signal. It looks like some of the internet is flaking a little bit. Hopefully you're able to hear me, though, because I can't hear anybody saying no. I can't get this slide to advance, so am I? Okay. I got the A-OK word now. All right, so here's a couple of probes. A probe on the left. You see, this. That's a 4-foot probe. We typically put them under the vine row, in the vine row, of course, and we install them right under emitters. We don't like the emitters to drop right on them, but we want them to drop right next to them. I don't have time today to show you why, but it's very important to put these sensors near a dripper because the actual drip pattern is not very wide. A lot of people think they go out for feet, on each, in a radius of like a foot or two, but they don't. They only go out a few inches, so it's a fairly narrow wetting profile pattern. So where we install the sensor is very important. Now you see one that's connected to. This is actually a Ranch Systems node. This is a one in Alexander Valley that was installed, but this is a very common way to monitor soil moisture is hooking up to a Ranch Systems node. And of course, that's why we're here talking to you. Here's just a little schematic of a probe in the soil, and you'll see that there's 6 sensors. And what I'm showing here is that how they measure it in very crude, non-scientific terms. They use a radio frequency signal to set up a radio frequency or electromagnetic field around the probe. So it actually doesn't touch the soil. It actually senses the soil through this electromagnetic field. And the electromagnetic field, which is actually created by what's called a capacitor. These are individual capacitors. They're basically plates where they pass a radio frequency signal through them, or across them to be more accurate. It creates an electromagnetic field around them. And that capacitance is actually influenced by the media around it. And just going back to just the soil matrix is basically made up of 3 large constituents, if you will. Mineral / organic matter, that's one. It's basically the solid part of the soil. And then there's pore space, and the pore space is either filled with water, or if it's not filled with water, it's filled with air. And it turns out that air and water have an 80 times different property, or 80 times factor difference in this property called permittivity, or called dielectric constant, which influences the capacitance. And that's how these devices work. So there's no water going in and out of the probe. It's totally sealed up. But the electromagnetic field will sense how much water is in the vicinity of it. Okay, so I'm going to skip a little faster here because in the interest of time, rather than talking about this slide in detail, I'm going to show you more or less by these charts how we use it. This is a chart. I bring this up a lot because it's got a lot of information in it, even though this is not exact at all how I would like to irrigate, because I don't really prefer to irrigate as erratically as this. We put this one in for a grower just as a demonstration, and they let them irrigate it how they wanted to, but it does, nevertheless, it shows some pretty interesting things. One of the things you'll see, first of all, what we're looking at here is of course, time, and this is looks like late September through mid-October of 2010, and this on the y-axis is water content. That's relative water content. It's not a calibrated volumetric water content. And as I keep trying to stress to people, you don't really need to calibrate these. And it's actually it doesn't really give you anything to calibrate them. And there's many reasons for that, and I wish I had time to talk about it. But you'll notice lots of things. Now, each one of these colors represents a different depth. Hopefully you can see that. The font's not very big on these charts, but 8 inches, 16 inches, 24 inches, 32 inches. And then we have 40 and 48. And you'll notice right away that the 40 and 48 are flat, and all the other ones are doing something. So moisture content is changing from 0 to 32, but nothing's happening down here at 40 and 48. So what is it? The probe broken? No, the probe's not broken. It means that there's no root activity down there. We did do backhoe pits in this one, and the 40 and 48, roughly around 36 inches is where we see a transition from a loam soil to a gravel, almost solid gravel with some sand in it. So it's a very strong horizon, or very strong, let's just say, stratification of the soil. And the roots don't grow into it. And water doesn't really go into it with drip irrigation. So what happens is essentially no root activity down there. And you can see that. So I told you before, you can dig backhoe pits, but if you stick these probes in, you actually can see right away, or at least within a week or two, where your root activity When we see that, it gives me real confidence that there's root activity in that area, and that's really a very strong diagnostic or informational source for me when I'm looking at these charts. You also notice in each one of these is a spike from irrigation. You also see that sometimes it activates or it changes the moisture content down here at 32 inches, and sometimes it doesn't. So it tells us pretty much exactly within, I'd say 4 inches, how far water is going during an irrigation. You'll see this one over here where they irrigated, and then a little bit later, I don't know, it's probably a couple hours if you blow this timeline up, that this green line goes up. So meaning that the water went down somewhere between 24 and 32 inches. So when we see the strong rise, that's a wetting front. But when we see this delay, that means it stopped above that 32 inch, and then it redistributed to wet the moisture, wet the soil below it. So we can really tell with pretty good precision how far our water is going. And so we don't want to irrigate or even try to irrigate down here. And trust me, you won't be able to get water down there. What will happen is hit that boundary and then start going laterally. So it goes back to what I was saying before with that shallow soil. This isn't super shallow, but with every soil that you're irrigating, you want to know what its characteristics are so that you can make your irrigations properly. I try to get to that depth, whatever depth I want to, every time. It doesn't always work that way, but that's the ideal, is to pick a volume that goes down to a certain depth and stick with that volume. The thing I change mostly is the interval between irrigations, the days between irrigations. The next slide here, this is just an example, similar moisture content. We see every level is taking up moisture, but you also see that these diurnals are going up and down instead of level. When I see that, that generally indicates there's some kind of hydraulic lift going on in the root system, meaning there's moisture down in deep levels, and it's being pulled up at nighttime through the root system. That's a pretty common occurrence, but to me, if I'm seeing this, I don't want to be irrigating. This particular circumstance, the grower is just a little bit premature in irrigating. We've since weaned them off of that early irrigation, and they're no longer doing this. But that's an important thing to look for. You'll see this early in the season when there's lots of moisture. But if I'm seeing this at the lowest level, like at 48, which is this, when I'm following with my laser beam there, when you see that, that means there's moisture even below that level. Ample moisture, and the roots are getting to it. Don't irrigate when you see that. This is the real powerful thing, that with these probes and with these volumetric type of, or these water content measurements, we can get a lot of really good. There's a really good way to look at it, and you can't get that from a matrix potential device because they're not. You can't just add them up. This is a summation, but you can use an average just as well of the whole profile. These numbers over here are totally meaningless. So, because this is a summation of some relative water content numbers. So I'm not really even concerned about that. And if I took an average, it would actually be more meaningful, which I do. We're starting to move more towards averages instead of summation. But essentially, we're looking at the whole moisture profile in one chart. And again, this is not an irrigation I necessarily would prescribe, but it does illustrate a few things. First of all, we see every irrigation, the water goes up, then it comes down. But you'll notice that it does come down after this. Let's use this irrigation. It comes down rapidly, and then it starts slowing down. And that's because the moisture becomes less available. The plant goes into some protective mode, so it closes its stomata and the leaves, and actually just is, well, for lack of a better word, it becomes stressed. And as this curve flat here, that when we've irrigated this is readily available to the vine. Then it goes into less readily available. It's sort of arbitrary. And so again, this is a very site-specific, non-calibrated, but we can draw our reference lines in wherever we want, and those can be used at that site to indicate where the water's available. And say we don't want the water to be so available, then we want to irrigate more in this lower range. Well, we can do that too. So here you set a reference point, call it refill point. You can set it down there if you want the vines to get stressed. Is indicative of vine stress. It's not a direct measurement of vine stress, but it does correlate to vine stress, and as the vine takes up less water, well, as the vine gets more stressed and the water is less available, its uptake is slower. So it's actually a lot of information in these charts. This is a more typical way I irrigate, it's more repetitive. This is like a weekly cycle, just to give you an idea of what I'm really doing here for the most part. And here we're irrigating down to about barely 32 inches. Sometimes it hits 32, but really we're only irrigating a couple, 24 to 30 inches. And I find that this is actually sufficient to keep the vines happy, but also slightly stressed, because we do have some dry soil as well. So that the soil down deep is dry, the soil up top is moist. The vines think they're stressed because they have this dry soil down here, but they're actually hydrated. So actually a really good way to irrigate the vines. And this is the summation of that same data. Again, we're trying to keep it within a certain bounds that we set. And this is kind of our target refill point. So that's the idea. And that's where I say that we don't need to guess anymore. So we irrigate, and we know exactly what the moisture content, or how long it takes to get from this point where we irrigated to this point where we irrigate again. If we want the vines to get more stressed, then all we do is stretch it out a day or two. And then the next one's going to be lower and lower and lower. That's a deficit irrigation. Now, if we want to irrigate, relieve the stress, then we irrigate more often, reduce the interval, and what will happen is this will start stair-stepping up, and that's a surplus irrigation. So everybody talks about deficit irrigation. This is an irrigation here, and again, I'm usually talking about 20% of ET. So don't tell me 60% ET is a deficit. It is if the vines are not under a water use efficient condition, and that's why I want to get them into some kind of a mild stress condition, because that is a water use efficient range for the vine. I use this as an example because this is the first time I actually calculated it. This is just the same thing. This is a different output because this is actually a ranch systems output. You see, we set these boundaries. This was just installed late July, and within a few irrigations, the grower figured out how much to irrigate and what cycle. This was actually about a 12-day interval. It's a fairly young vineyard. We didn't want to stress it. You see this kind of repetitive pattern. And so I've used that data, and I've looked at it like this, and I've seen we've irrigated once here, we irrigated once here, then we're about to irrigate again here. And that was, these were two 6-gallon per vine irrigations, and this was the reference ET during that period of time. This is the crop coefficient I used, 0.5. So the crop ET was actually 2.21, 66 gallons per vine. We irrigated at 12 gallons per vine, which means I'm only irrigating at 18% of ET. And I've done this a few times, several times since, and every time I do it, I'm always around between 18 and 22% of ET. So don't be telling me 60% is a deficit irrigation. That's what I keep saying, and I believe it. I just touch on plant stress monitoring because it's very important, but that's not really the crux of this discussion. It's important to measure the plant stress in some fashion, even if you're just measuring it visually. These are the shoot tips, and we look at this. Actually, I should have put the more recent one in there. I have another slide photo image where there's like a second one where it's between this rapidly growing and a more slowly growing. I did this late last night, and I guess I forgot to put it in there. But you see, the various stages of stress developing in the vine, and this is kind of what we're looking at, probably even more than the instrumentation. Early in the season, we're looking at the shoots to slow down, so that we can irrigate them when they, they need to be irrigated. Not when, if we irrigate them over here, then they're going to continue to grow. That may be something we desire in a struggling block, but in most cases we don't want excessive vigor, so we want to let that moisture deplete on its own, let the vines extract all that moisture before we even start to irrigate. So we're not usually irrigating somewhere in this area. The other tools we use are the pressure bomb on the right, on the perometer on the left. A lot of people are familiar with the pressure bomb. Not too many people, well, I think a lot more people are now understanding the perometer. Hopefully that has something to do with that because I've been promoting it also. It's a great tool. I find this tool to be more useful than this one. As great as this tool is, the pressure bomb, I'm more inclined to look at the perometer numbers first. Again, I don't have a lot of time to talk about what that means today, but just to put you on the in the ballpark, this is a sliding scale of stress, being on the left side too much water, on the right side too stressed. Then we have kind of a target range. And this depends on variety. Now, white varieties maybe not, you don't want to get them as stressed. Red varieties, though, we're trying to get them over in this range. So this is our leaf water potential, negative. This should be negative, but I'll put negative here. So 8 bars here on the left, which is not stressed, up to 17 or 18, which is extremely stressed. But for the perometer, which a lot of people aren't as familiar with, we read in units of millimoles per meter squared per second. And when we're using those units, and when we're over, the vines are too happy, they're over in these 300 or 400, 500, even higher levels. But when we get them dialed in, this is the zone. I call it the zone, between 100 and 160-ish range for like Cabernet, for some of the Bordeaux varieties. Not Merlot. Merlot is a little bit more sensitive. This is the area we want to get them to, and this is kind of the sweet spot for wine quality and for water use efficiency. Just a quick note on timing of water stress. This is kind of the timeline between bud break and harvest. We want them to be non-stressed between bud break and fruit set. We don't want them to be stressed at all during fruit set. After fruit set, though, we can start putting them on a stress. And so we'll typically do, we don't have a lot of control here anyway in the North Coast because we're still depleting rain moisture, winter moisture at that point. So I'm actually letting them go. I don't usually don't irrigate until I start getting them to this point. But that's not going to be the case everywhere in California. In some areas you are going to have to irrigate earlier. But I want them to get to this range, this zone, this stressed state before variation. Something called, I call the magic window, but some people refer to it other terms. But there is something real going on here, and getting the vines stressed before any sign of aeration is actually important. You get that stress on before aeration occurs. There's lots of physiological things going on that you don't see. Of course, by getting the stress on there at that time, we're reducing the vegetative growth, but we're putting the vines into a water use efficient range, meaning the leaf stomata are partially closed but not completely closed. They're open enough to allow CO2 for photosynthesis, but they're closed enough to reduce water use, and that's actually what really helps on multiple levels, but really on a whole water use, vineyard water use. Getting the vines into this state is super important. It also has something that we're finding out at a gene transcription level, down at the genetic level. They're actually finding that the stress of water stress, the mild stress, is actually producing more of these ripening enzymes in the fruit, which take over during the ripening. So actually we want to get these things in place before ripening starts. And one way we can do it is with some mild water stress. It's mostly effective in red varieties, so anything where we're dealing with phenolics, and the properties of the red varieties are more beneficially stimulated than whites, because whites were not really dealing with phenolics. There's some evidence that potentially that whites are benefited as well. But overall, what we're trying to do is getting flavor ripeness at a lower Brix, and that seems to be the trend in the industry, which I think is a good trend. And we've been able to do that with irrigation, careful irrigation management. I see that I'm running kind of late, so I'm going to I had these case studies to discuss. I'm actually going to have to just skip that for now. And I've talked to him before, and if I can make this available, this presentation available to you if you like. But basically, we're looking at two different sites that are irrigated very differently. And without getting into all this, I'm going to skip and do a really quick live demo and open it up to questions. We are getting up to the end of the time. Let me see if I can do this without too much of a problem here. Am I still live here? Hopefully you can see this. Mike?
Yes, you're live.
Okay. Really quickly, this is the Ranch Systems interface for one site. This is our soil moisture. I have this, I don't want to make confusion, but this one over on the right has a calibration equation and this one doesn't. There's a reason for that, which I won't go into, and I'm actually going to change it back to this after this discussion. But we have it's very easy to look at this soil moisture data in real time. This is a site in the Russian River, a fairly moist site. These numbers don't mean a whole lot to you. I'm going to go back to a year period, and hopefully this won't take too long to get on the screen. We're pulling in data from for the whole season last year, essentially from April to the current April time frame. This is a stacked view. So we're looking at every level here individually, from the 8 inches here to 48 inches. The nice thing about this view is you can see the individual levels very clearly, and you can see that this is all the winter rainfalls, and that it took a while, but eventually the rainfall did wet down to this 48-inch level, which is here at the bottom in green, and it's pretty much held that way through the current present day. That's a very nice way to look at it. There's other ways to look at this moisture content. Again, I'll go back to the year. This is where every one of these moisture levels are overlaid on top of each other. And if you want to see certain ones of them, not the others, you can click, make them disappear. So here we're only looking at the deeper levels. Or we can bring them back. We can only look at the shallow levels. Very interactive. And you really can't see it very well, but I'm hovering over it and it's showing me the actual water content of that level. Up here we have the average of all those sensors, all 6 sensors. And we use this, and again we've set our guidelines down here. You see this little bar here. That's kind of our target. You see how we are right now. This is actually current as of 6, well, it looks like 6 a.m. We have a lot of water left in the soil profile, and so we let it dry down before we irrigate. You see in this particular site, we didn't even irrigate until August. We only irrigated a few times. There's something new that I'm not too familiar with yet, but I did want to bring that up. It's a new feature that Ranch Systems is developing or has developed. I think still needs a little bit of work, but I think it's pretty close. It's called Live Map, and this is showing our site with these 2 probes. It has 2 probes in it with dots showing the probes, and these can be adjusted. We can adjust the color of these, or the levels at which these dots show, so they can show if there's plenty of moisture, they show green. If there's very, very low in moisture, we show red. This one's showing red only because I have it non-calibrated, but I just wanted to show accordingly that we've seen the vineyard, and we can set our root regions for each of those states. So more shallow root system early in the season and gets deeper as we go. This is kind of something you have to play with. But we can also set our stress targets. So we can use this as to set up some guidelines that go along with the phenological states of the vine to develop stress level targets or water content targets. I'm still messing with this. So, like I told you, we want to get the vines more stressed, so we've dropped our target, and we dropped our target zone. And then after veraison, we don't want as much stress, so we can relax that stress. And so we've changed. So this reflects our basically our target water content levels for each for that particular site, based on that prescription that we showed. They call it campaign. Now post-harvest, then we can let it go less stressed. In this case, they didn't have that much water available, so they couldn't let it go way back up here. But so it did so after it started raining in December of last year. Anyway, you can see, hopefully you can see that this is a really tremendously valuable tool. It gives us consistency from year to year. It does take some time to learn about each site. Each site's different, but we develop these tools around it. We develop this history. We can probably use this as a template, potentially use this as a template for the following year, or maybe we have to make some adjustments to it. That said, I think I'm going to cut it here and then open it up for questions. We are over time already.
Oh, that was great, Mark. Thank you. So I'm going to start reading the questions, and those of you out there, feel free to ask your questions and type them in, and we'll start going through them. So, boy, there's a lot of questions. So we're just going to go through these in the order which they were asked. So the first question is, how does vineyard elevation affect amount of water that needs to be applied due to higher evaporation rates?
Elevation, if we're talking about extreme elevations, as in thousands of feet, can have an effect on UV, ultraviolet. It doesn't have a lot of effect on other things. Typically, when we see the high altitude vineyards, we have thinner soils. This hillside vineyards tend to be thinner soils, so that's going to affect it probably more than anything else. So actually, the high elevation vineyards aren't necessarily using more water than low elevation vineyards. It's more, the evaporation and evapotranspiration and transpiration, let's say that, is mostly a function of vapor deficit, or vapor pressure deficit, if you will, which is a more technical term. It's really how dry the air is. So in wind has a lot of effect as well, because it's moving that vapor away from the leaves. That has more of an effect than elevation itself. Now, elevation is going to be a factor, but it's mostly going to be dealing with the soil water content more than actually the environment, the aerial environment.
Okay, next question, Mark, is could you please post the reference for the stimulation of ripening enzymes when moderate stress during veraison is achieved? I'm not sure I understand that question, but perhaps you do.
Yeah, they're looking for a scientific reference. There is something published, but it's a pretty thoroughly genetic from Kramer in Kramer's group and from University of Nevada, Reno. I don't have the references in front of me. Maybe I can stick it on the presentation or somehow disseminate that to the group if you're interested, or contact me directly. There's also been some work done by Mark Matthews at Davis. I'm not sure if it's published yet. It was presented about a year ago, maybe I think it was a year ago at Davis. One of their, I think it was one of their conferences that was presented. One of those columns.
So, Mark, if you get that reference to me when I do the follow-up with the link to the recorded webinar, I can include that.
Sure.
In that
sure.
email.
Yeah.
So, next question is, in your sum graph for soil moisture, are you expressing the vertical values sum in millimeters, percentage, or scaled frequency?
Scale frequency, that's interesting. That's pretty much what it is. I've heard it called scaled frequency, and that's, I don't even know what that means. But it's a relative water content. I call it relative water content number, 0 to 100. And 0 to 100 doesn't mean a lot physically, but it does when you, in practice, get to know these numbers. And so that's a number that's based on their what I call relative water content. And that's why it's essentially a meaningless number. If it's an average, then it's a little bit more meaningful. You can actually apply these calibration coefficients. I think it's a fairly inaccurate calibration because soils are not, 5 classes of soils. There's lots of them. There's lots of variability, and there's horizon differences. It's actually pretty complicated and very inaccurate to try to calibrate these. And when you do, then you can put them into inches or millimeters, and then you can sum them up that way. And that's actually fairly, a good way to look at it. But honestly, I don't use it in that fashion. I do these site calibration. I call calibrations, but it's really just fine-tuning that your chart, looking at these guidelines, and I'm putting these in there for every site. And so every site, we're learning a little bit about each site and applying it to whatever numbers on the y-axis. To me, isn't that important. I'm again looking at the shape. Are they getting stressed? Are they when's it coming back to that same reading? I'm less worried about the actual number than I am the patterns.
From the curves, how do you determine the irrigation amount? You have a set point, but when do you stop?
Yeah, the way I do that, it's a little bit of an iterative process to begin with. When you first start doing this, is to put on X number of gallons. Maybe you start out with 3 gallons or 4 gallons or something, and see how far down it goes. And if it's going down to where you want it to go, then that's your number. But oftentimes we're doing that. Well, let's try 2 gallons more. Let's try 2 gallons less, until we get it tuned. It takes about 2 or 3 or 4 cycles before you get it right. It's not the moisture content here that we're looking at does not tell you how much to irrigate. In fact, there's no way you can make it tell. With drip irrigation, it does not ever tell you how much you need to irrigate. So we have to use that little learning process. But once we've figured out that ideal amount, it's usually pretty consistent for the rest of the season and actually every year thereafter. So kind of pick a number that works for that vineyard and that site, that block, and then go with it. But it's not a direct measurement of how much water you need. It's a identification of the pattern. Looking at these charts and seeing how far the water goes down and how far do I want that water to go down. How deep I want that water to percolate.
Next question. Where should the leaf parameter readings be in the post-varation period in order to promote phenolic ripeness at lower bricks in Cabernet Sauvignon? It's a very specific question.
It's good. It's a good question, and it probably applies to a lot of other varieties besides Cabernet Sauvignon. But again, I like to get the vines into that range of, say, 100 to 150 millimoles per meter squared per second at a couple weeks before veraison, and then I'm going to hold it there through veraison, and oftentimes I keep it there for the rest of the season. And I actually think that's the best way to go. Even though you get most of your, I say, bang for your buck, that stuff I was talking about, which we're trying to find a reference for you guys, is before veraison ever starts. But through the ripening period, I also like to keep the vines pretty close to that level. So within that window, so maybe we want to get around 110 before veraison, hold it that way, then maybe we let it go up to 150. Closer to harvest, and that's mainly the purpose there, is to keep the leaves functioning and happy and photosynthesizing. But photosynthesis in California vineyards is not necessarily all we need. It's really almost a detriment, because we're trying to avoid that high sugar. We're trying to we want that phenolics ripeness to occur. So holding back sugar is not such a bad thing in this climate. Well, we have like a surplus of sunshine, but generally, what I'm doing is trying to get it stressed into that range, and holding it for pretty much the rest of the ripening, but maybe going to the top end, as we get towards ripening instead of the bottom end.
Okay, what is the water potential just after the irrigation event? I think what is the water pot? I imagine that means that's short for potential.
Yeah, water potential. Well, I mean, it depends where you started, but generally, yeah, the water potential does spikes. I'm going to say way high, because we're talking. These are it's always a hard thing to talk about, because when you do water potential of the plant or soil, we're always talking in negative numbers. So basically, you're going to go from maybe anywhere where you were before, from like 14 bars to negative 14 bars to negative, say, 8 bars, but it's hard to say exactly what it does. Water potential does change rapidly following an irrigation. Stomatoconductance does not change as much following an irrigation, because stomatoconductance is controlled by hormones, plant hormones, more than it is water tension. So you'll see a big change in water potential right after an irrigation. How many bars, it depends on where you started, like I said. It depends on lots of things. It depends on the soil, texture, again, where do you start? But the thing about drip irrigation is you're irrigating just a small portion of the whole soil. So the water potential is changing right there where you irrigated, but it doesn't change, a foot away. It's it's the same place it was before.
Okay, and let's see, one more question is that how do you go about determining the interval of irrigation?
The interval? Oh, okay. Well, that I got this on the screen, so let's just look at it. Hopefully you can still see it. Can you still see my screen? Or no?
Well, let's see.
Can you see this? Oh, you have
hold on. I just launched a poll, so
well, I can describe it. But really, what I'm doing is I'm using that either summation or the average water content in the profile, and setting those limits up at. Usually, it's the lower limit that's mostly important. The dry side, the bottom, the lower water content. And so I'm using that single line, not all the multiple lines, but I'm using that single line, which is the summation or the average, because it's kind of it's a summation. It's sort of a synopsis of the whole root system or the whole profile. And I'm using that as a guideline. So if I irrigate, it goes up, and then it takes a while to come down. Every day it's depleting more moisture. Eventually it's going to come down to exactly that same point where I started. And so if I want things to stay the same, then I irrigate at that same point. So the number of days it took for that to come back down, that's my interval. If I want to deficit irrigate and get it more dry, then I'll stretch it out and let it go. But if you do that, then you're going to get more stressed, and that's where the vine water stress measurement is very important to do in accompanying the soil moisture. But that's what determines the interval. Again, I like to use more or less a fixed volume, which is the fixed gallons per vine, and then adjust the interval as we go through the season and try to get the vines into a certain either to maintain that stress or to relieve the stress. But that's exactly what I use. Is I use that chart, and that's not using a model. There's no ET involved because I'm actually looking at the water content that was put on there through irrigation is being depleted by the vine.
Okay, I don't. Your screen is back. That was untimely launching of the of the poll. So in the poll I just launched, Mark, I asked if anybody was interested in learning more. So we'll be following up with anybody that indicated they were in it.
Yeah. Okay.
Go ahead.
Yeah, I don't want to interrupt anybody's poll. I just wanted to make sure that you understood, because it's a really important point, and to me that's the power of this tool, is that you got this, and hopefully you can see it. You've got this water content, and we set these boundaries based on our experience and based on our plant stress, and then we irrigate here, and we see this is a day, this is a day, this is a day, this is a day, and then we get back to close to that number, and we irrigate again. So we can really use that as our guideline to determine the interval to answer that last question. And that's really, I just wanted to show that. But if you want to go back to your poll, go ahead. That's all I had to say.
No, the poll's closed, and we can see your screen now.
Okay.
So I think that is the end of the questions, and if anybody has a final question, this would be a good time. We'll just wait for another minute or so. Meanwhile, Mark, that was excellent as always, and I saw that was really that kind of a more. It's been different than in past years. It's kind of more focused. I think you've kind of refined your approach further from what I can tell.
That's because they always take too long.
No, it's again excellent as always, and thank you. And
Sure.
It looks like there's no more questions. So to those of you out there, thank you for joining us. If you have, we'll be following up for those of you that wanted to indicated the desire. You could also just contact Mark directly. His email is mark@advancedvit.com. You could contact Ranch Systems directly by emailing sales@ranchsystems.com. And thank you for attending, and Mark, thanks for sharing your knowledge and expertise.
Thanks for having me. Thanks for showing up.
Okay, very good. Goodbye, everybody. That'll